Problem number 2 from worksheet 3. We have this bridge, and they give us 3 of the forces for the car, the truck, and the bridge itself. But there are also a couple other forces here that they're leaving off, and I want to go ahead and draw those in here. And that would be a reactionary force at A and a reactionary force at B. And so now we can write an equation that would be F at A plus F at B, they're both up, will be equal to the sum of the other forces, since those are all down. Which that would be FA plus FB would be equal to 36,000 newtons. But we have 2 unknowns, so that's not really going to help us figure out FA, force of A or force of B. So we're going to have to figure out a pivot point. So you could put the pivot point wherever you want, but one of the easiest places would be at one of the 2 unknowns, because it'll eliminate the torque from one of those 2. So I'm going to put the torque over here, or the pivot point over here at A. So in this case, my torque equation becomes, I have the torque from the car plus the torque from B will be equal to the torque from the bridge plus the torque from the truck. So that's going to be 8,000 newtons times the distance away, which is 15 meters, plus the force of B, which I don't know what that is, times the distance away, which is 70 meters. That's going to be equal to 20,000 newtons times the distance away, which is 35 meters, plus 8,000 newtons times the distance away, which is 50 meters. Okay, so now I can go ahead and solve this for the force of B. That's going to be equal to $14,000 newtons. I can then plug that into the equation up above. FA plus 14,000 newtons equals 36,000 newtons, which means that FA would be equal to 22,000 newtons.